important things. Otherwise, I need to redo it. Okay, so that sounds good. I think that people can hear me well. So let's start the class. Let me share screen. Yes, okay, good. And great. So we talk about, I mean, different sorting algorithm. And again, you may consider the whole things as some understanding about the algorithm. That's the whole goal that we are talking about, not just writing the code, because we already discussed about STL or the similar things in Python that you can do the sorting. But these are important ones because especially if you have a large data, these are become very interesting. So it is, I mean, and I will say these companies, like for example, you may think about companies like Microsoft that now owns LinkedIn. So you may think, okay, sorting and like searching, these are some kind of things that are already solved. Of course, yeah, for small data, they are solved and you can get it. But when you go for large data, it can be quite non-trivial. So one good example of that would be just show that. Yeah. So one good example of those type of things are, for example, LinkedIn. That if you go, and I think I might have mentioned this before, that go there and then your two friends. You go and then you will ask for like you follow another person or like send an invitation, and then it becomes pending for that person until that person accepts you. So such that you have the, I mean, you can follow the person, but also you are inviting that person also connects to you. That takes time because that person possibly should approve that. And this invitation actually takes some time, like 15 minutes to go to that person. See, you are 2 person. We were actually, that happens, that we were 2 people next to each other. This person is like, I want to connect, but the request came to me 15 minutes later. And you cannot believe this is like the things, LinkedIn, Microsoft, they have all cloud, etc. The same thing, for example, if you are using Instagram, go and look at it. I mean, there are some of the basic stuff that you are doing that you want to, the messages that you are getting it. For example, if you have lots of views for some of these, the messages that you will get, it like you will say newest first. Not always the newest first is working. You need to maybe do it once or twice. And sometimes the sorting is not things, it does not bring the newest things. So you see, this is a very basic stuff that becomes non-trivial. For these, and these are the companies, these are probably the most advanced tech companies. Like lots of machine learning things are coming from Facebook, or like the cloud stuff comes from Microsoft. The same thing for Google also. One good example about Google, I don't know whether you have tried or not. I have, this is the thing, if you want to use Google Drive, you go there at the Google Drive. That happens to me a few times. I have uploaded maybe 2 gigabytes of data in Google Drive. The uploading goes correct. But then downloading it, I do it, download it. What does it do? It tries to zip it and then send it. I have done it a few times. Almost all the times, some part of, like you have several directory, etc. Just bring some of the files of that directory when you download it. That does not bring everything. Or like another example, they become a bit better at Google, but the Google, the Gmail search was not fun things. It cannot find some of this basic stuff. I think they became better, but they are using some randomized algorithms than others. And like, that is not, I mean, I think it became better more recently, but a few years ago, it was very bad. You couldn't find some basic search when you are doing for something. And again, the Google Drive still is bad. It's not the one that as far as I know, when you go there, the big file, small, it works fine. But like 2 GB of data, you will put it there. You want to download it on another computer, not all the files are there. And these are the top companies, tech companies. And these are like the basic problems that have here. Why? I mean, of course, they know about source and search and these things. But the issue is that when you are talking about this algorithm for big data, then any simple stuff becomes quite non-trivial because they cannot do this, for example, sort or search or this type of things, or other things. For example, if you go to both LinkedIn or this Facebook, Instagram, etc., that if you have several comments, it just brings the first 10 comments. Then you need to ask for the next 10 one and brings that. All of this simple stuff, it becomes complicated because you have lots of users and you need to answer them instantly. And with the given resources, if you don't do the most efficient way, then essentially you are doomed. That's the reason, and these are the things. So even this basic stuff, I want to say that when you go to large data, it becomes quite non-trivial. And to design a new algorithm such that because there you need to also design some infrastructure, like you need to think about the databases, etc. But the best way to do that, first you need to know the basic stuff. What is the idea that this works? Then you want to change it such that it works even for large data. And that needs a deep understanding of the current, like the basic stuff. See, how can I do that? Because this is the algorithm. Now I want to do it with large data. I have lots of databases. How can I make sure that these databases also answer in the right time? Or this is another thing, for example, at the Google for advertisement, the display advertisement. When you go to a page, even I think currently, actually, it is the case that like you may go there and this advertisement may come a bit sometime late because generally in something like around 100 milliseconds, the advertisement is a lot of complicated things actually happening for advertisement that some advertisement comes up actually. And lots of auctions, lots of things happen, such that one advertisement that you are showing, for example, you go to CNN, you will see some display advertisement, or some other pages, you will see that. Very complicated things happen there, essentially. And all of them should happen in 20 milliseconds, like between 20 to 100 milliseconds. So you need to know the basic stuff such that you can run this thing. But anyway, about the advertisement, this week, I think next Monday, this is the potentials of e-commerce. I talked previously some part about advertisement, and I will go in more details about how does advertisement works. And I think it would be a good one because I didn't know, I mean, some of them until I had with some of these companies that I understood. So it took me some time to understand it. So it would be a good idea to actually understand them well that I'm presenting it there. Anyhow, so that's about this one. I want to say that this basic stuff we need to know, and both in terms of learning how we can, I mean, prove something works and why does it work. And in this terms that, I mean, if you want to generalize it for big data, you need to have good ideas. Good. Now, with this introduction, let's go and talk about some other type of sorts. And next week, also from next session, I will have 1 or 2 sessions. We talk about some kind of probability theory and some basic stuff that you may have it for this course and the future courses. But this is like a crash course on probability theory. There's lots of things that you need to know. Actually, it is there. Good. Now, let's talk about these things. Today, we want to talk about bucket sort and the radix sort. So the bucket sort is the simple idea that, I mean, the kind of call it mailroom sort. That you have, when you want to sort something, and this is some idea, actually, you can easily implement it if you have databases. So this is like a interesting one that you can actually make it more efficient algorithm if you have enough databases. So you want to allocate a sufficient number of boxes called buckets. And then you will put each element in some corresponding bucket. This is called a bucket sort. So, for example, assuming that there are some of the elements, these are just some kind of letters, and you want to sort them according to the state. So in that case, I mean, like you want to send it to different states. So you have, if you have 50 buckets, then you will put each one in the different one, and then you have actually, you have sort them according to the buckets, according to the bucket that this, according to the state that this letter should go. If you want to go according to zip code, actually you need to have more buckets, like almost, I think 100,000 buckets, because we have 5 digits. So in general, this idea of bucket sort is a good one. And actually it is also some kind of a base for radix sort or radixsort. It works quite well when the ranges that you are dealing with are small. And this is, I discussed before that, like for sorting, you cannot do it better than n log n. And this log n can be large again for big data. Just think about 1 billion people, or even, I don't know, trillion number of messages that are going every day. Then in that case, n is large. So log of n is important. And we are talking, for example, for advertisement, that you need to get the answer in like, you need to show the advertisement in less than like between 20 to 100 milliseconds. So you have a very small amount of time to do that. And of course, if something is, I don't know, 20,000, even 20 times faster than other algorithm, you may want to use it. So when it's a big data, every constant matters, that they are not generally for a smaller data. So if you have a small things, actually you can do it something much better than a small range that you want to sort. You can actually do it better than quicksort, or I mean, quicksort we will talk more, but merge sort or others. So think about this way. So if you have n elements ranging from 1 to m, then we need m buckets. So m buckets, what are these m buckets? For the different values that these guys, they have it. So how can we do this bucket sort in general? If you have m buckets and then n elements, then each of these elements, you will just put it. So you will consider the elements, you will go through the all elements here. For example, if these are the elements A1 to AN, you are going through these elements, order n. Each element, you are putting it in the corresponding bucket. So you have the buckets for each of them. How many number? These are m buckets. And m, what is m is the range of the items that you have it. Then each of them, you just go there and you will put it the corresponding things here. Maybe there's actually this one, the second one goes here, and so on and so forth. So you will do that. And then you are doing another order m now to go through these buckets. And for each bucket, you will just go from the first bucket to m bucket, like that, or m minus 1 bucket. And you will give the output. Any one which is non-empty, you will just output the buckets. That actually, the running time of this algorithm would be order n plus m. The space that you needed for it is order m. And it would be good if m and n are in the same order, but if m, the ranges can be much larger than n, this is not the most efficient way. Good. So is everything clear? Great. So let me. So that is the one that we can do it. Now, let's go to the next algorithm, which is the radix sort. Is everything clear? So this radix sort algorithm, it is also called least significant digit sort. So in some sense, there is no one-way sort in some sense, especially when the data becomes big, you should decide which one you want to do it. And these are exactly the ideas that I have used it. I mean, when I decide to this kind of infrastructure for the companies, etc., that you need to have this idea that when you go with the databases, you need to be quite familiar with these things and say, depending on the conditions or the constraints that you have it, you need to decide which one I want to use it. So there is no one sort that is always better. It depends to your data and how large is it, what are the constraints that you have, etc. So this one, least significant digit sort. So what do you do essentially? You will start with the least significant digit of each key. So we are always assuming that this data that we have, one column is the key. Or you can consider, I mean, sometimes the key can be also a pair or a tuple. That's fine. So you will, but say for now, it's like one key essentially that we consider. So you will take the least significant digit of each key. And here we are considering, say, these are the numbers that we are considering. So you will consider the least significant digit of each key. Say in this case, are numbers. Then you will group these numbers according to that digit. Otherwise, so those numbers that they have the same digit, you will put them together. Otherwise, you keep the original order of the keys. So if someone is coming before that one, you will keep the order. Repeat this process now for the next least significant digit, and so on and so forth, until you will go for all digits. So you start from least significant digits. You have some original order. You don't always change the order. So those guys that they have the same digit, you will bring them together, but you don't change the order. And we will talk how can we implement them actually nicely. Then the digits, you will just put them. This is in that part, it is some kind of like a bucket sort. As I mentioned, bucket sort is somehow the initial ideas for this other more advanced. You will do that, and then you will just keep the order, and then you will go to the next significant digit until you are done with it. We want to see what is the running time of this. Let's see an example. That's actually a good example here. We should see it here. Good. So this is the example that we want to talk about it. So these are the numbers that are given to you. And say this is the array. So this is A0 or this is array 1 and so on and so forth. Good. So we are starting by the least significant digit, sort by least significant digit. So what is the least significant digit in this case? So it would be something like, so here 6, 2, 4, 2, 0, 5, 5. So what do? We bring those guys that they have the same digit together, group them together. But otherwise, we don't change the order. So, like for example, here we are starting with 0. We are first bringing all 0 guys. So 170 is here. So 170 comes first, then 90 because 90 was here, and then it was, yeah, these two were the 0 guys. There is no 1 guy, so we don't bring anything. Then there are 2 guys. So what are this one? There is 802. We are bringing it, and then 2 because 2 came later. Then there is no 3. Then there is 4 is 24. We will bring it. Then there is 5. This is 45 and 75. We keep the order and 66. So that's the one that we have done it for the first stage. Okay. So is it clear? Now we will do this one for the next digit. So what is the next digit? Then it would be the essentially the tens. So here we are going again. Now we are considering the second digit. So the second digit would be here. It would be 6 here. Let me just do it with a different color. So I have it here 6, 7, 4, 2. Here it would be 0 for these guys. This 9 and 7. So here, if some digit is not there, we will just consider it as 0. So in that case, what will happen? So here, first we bring the guys that have 0. So this is 802 and then 2. Because 2 is 0. Then we will bring the guys that they have 2 in the tens, which is, I mean, there is no 1 in the tens, so there is 2, then 2, 4. Then after that would be fourth, we will bring it. Then there is 6 that we will bring it. Then there is 7 that we will bring it. There are 2 7, 170 and 75. And again, because here 170 came before 75, we will keep the same order. And then 90 is coming, the line. So that's the thing one. And then we are going to now to the hundreds. So for the hundreds, essentially, almost all of them are 0. So this is 0, this is 0, this is 1. Let me just do it with a different color again. So for the things, I have it 0 here. Then it is 0 here. This is 0 here, 0 here, 0 here, 0 here, and then 8. So here, again, we are sorting that. So first, we are bringing all 0 guys according to the order. So this guy 2 is coming, 24 is coming, 45, 66, 75, 90. All of them are 0 guys that are coming, all these 0 guys. Then after that, the 1 guy comes, which is 170. And then 8 guys coming. So you see that this 801, it was just the first element until the last things. Then it goes to the correct things. And then we have the sorted. Good. So that's the essentially the algorithm. This is the least significant digit sort. Now, to understand it better, we want to see what is the running time of this algorithm. So if you have k digits, the maximum key length, so key is the maximum, the number of digits or the maximum key length, then we want to say that this algorithm running time is order nk. But I mean, it is not completely trivial. How can we do it nk? So, okay. So the fact that we are going through all the digits 1 to k, so that is order k, naturally. Then we are going through all these numbers. But the question is that how can we do this grouping together? Good. You might be able to use essentially a dictionary or like in some sense. So one way to do that, if you want to do it in Python, for example, let me just So, good. Okay. So one way to do that, if you want to use it at Python, is that you can have a dictionary. So for each of, so in some sense, this is the way that you can have the buckets. You can have a dictionary, and each dictionary is each element of the dictionary is a list actually. Good. So for each of these digits, I mean, it can be digits or it can be actually even letters. You can be hexa numbers essentially that you may want to sort them. So you may have these digits. So for each of them, you have a dictionary. And then this dictionary is a list essentially. Each element of this dictionary is a list. Good. So you will go there. So you will just 0, 1, 2. So this is the dictionary. So the same thing actually you can do it also with the, say for example, if you want to do it with C++, instead of dictionary, you have a mapping here. And then the other one would be the linked list that you have. Now, you will go there and then all of them at the, so what you do, you will go through each of them, each number that you will read it, according to which digit is there, you will include it in this list. And say the list should be initialized to be empty. You will insert them. And of course, the order will be, so always when you insert the new guy, you will put it, because you want to keep the same order, you will insert it at the end of the list. You will do that, and then you will go one more time over that and read it. And then for any list, you just put them essentially in an array. So the new order is that you will go to the first, like the first item of the dictionary, and then you will see bring the whole list, and then go to the second one, bring the whole list, and so on and so forth. So that's one way that you can do it essentially. So this is a dictionary that you can do it in Python. Or you can do it in mapping, which is the C++. Good. However, if you don't want to use this one, so if you just want to do it everything in one array, not using this linked list, and in some sense, actually, if you want to do it, the whole thing with just 2 arrays, but you can do that. You can do this one. So you will have your first array that everyone is essentially is there. Good. Now, you will go and for each, so then you have these buckets. I mean, this is the one that actually, this is the one that I drew it. So you will say, how many zeros do you have? So zeros always, so this is another array, temporary array that you have. So it says 0, 1, 2, 3, and so on. So 0 always starts from 0. So 0 always starts from 0. Good. Then you will count essentially how many zeros do you have in this array. In this particular digit, how many zeros do you have it? Say you have it 10. Then you will see how many you have it for 1. So then it would be, say, 5, 1. Then this would be 5 plus 10. Sorry. So that would be 15. Then you will count how many 2 you have. So maybe it is no 2. Then it would be the same thing. 15 plus 0 would be 15. And so on and so forth. You will do that. Good. What are these guys? These are actually pointers. So these are like, maybe actually this is the original. So let me just erase this one. So these are pointers actually to a new array that you have. Good. So 0 comes to here. then 10 goes to the 10th element here, for example, and so on and so forth. 15 goes to here, and 15 goes to here, same place, and so on and so forth. Good. So these are pointers to a new array. So this is the original array. This is some kind of essentially the temporary array. Good. So what did you do? So you are essentially considering this original array. You will go through the original array. You will count how many digits you have. Based on that, you are creating this. This essentially, this is the temporary array. I don't know. This is a counting array, or the pointer array. So counting or pointer. So this counting or pointer array, you will go there, you will create these things. And then what do you do? So all of this, what was the running time of all of this so far? Order? No, this operation that I'm talking would be order n, correct? Plus probably k, order n plus k. So, good. So here, yeah.
Why would it be plus k?
Because of this counting array. You have k digits here, correct?
I thought k was like the length of the key.
K was the length of the key. Yes, yes, you're right, actually. So we don't have this case. So let me, thanks for that. Thanks. So yeah, the number of digits would be at most n, we are assuming there, essentially. So let me just erase this one. So that would be order n to just go through this array, read it. Here we are just doing the counting because to do the counting, actually you don't need to do it. So anytime that you are going there, you can actually create another counting array first. So from there, you will say, you will read each of these items. Then if it is 0, that digit, then you will add one to this. If this guy is 1, then you will add it 1 to here. If the next guy digit is 1, then you will make this one 2, and so on and so forth. So first you are creating this this I will say temporary counting or temporary pointer array. So first you are creating this temporary pointer array, and this order n essentially takes to do that. Then from this one, you are going and then creating this counting or pointer array. So each element would be just some of the previous guys. Actually, the first guy would be 0. Then the one guy would be just, so here, that would be the way that you can create it here. So you see, here always the first guy would be 0. Now, one guy would be the first element here, the number of zeros. This guy would be sum of these guys and these guys. This guy would be sum of all these previous guys, and so on and so forth. And you can do all of them essentially in order n at most. You are creating this pointer array there. Now, when you have this pointer array, then what do you do? Then you are essentially done. Now, what do? You will go from here, you are starting another order n. You will go from here, the first guy. So you will see the first guy is 0, that digit. You will insert it to the pointer array. So I will, this is 0. So this is the first guy. Maybe it is, I don't know. This element is 0. So you will add it essentially to here. Then you will increase the pointer for this guy. So the pointer here now goes to the next guy. Then you will come here. You will say again, oh, it is for example, 1, 0. Is it the number is 1, 0? So then you will just add it again to this point. And then you will, this advances one more. So these pointers for each of these digits say that what is the current place that I should insert this element when I see an element with that digit now. Then this guy is 1, for example. Then you will go and insert it in the 1 place, and you are advancing this pointer to 1. And so on and so forth. So you are going a linear search, a linear scan on the array. And then each array actually now, each element will be inserted in exactly the correct place. Good. So after doing that, actually this temporary array would be exactly the array that you want to have it. Now, what do you do? Then you don't need to actually copy this temporary in the original. Now you can, this temporary is the current sorted things. Then for the next digit, this guy can be original and this guy can be temporary. So this can be original now. And this guy is the temporary. So you are switching between these two arrays. And of course, you will initialize these guys again. So you need to do this initialization again. So this is the initialization that you need to do it again. So on and so forth. So you have sorting it using just 2 arrays here. So here we don't need to have any linked list or anything essentially, because each of these one, how there exists, there are some overhead. So if it's a large things, this might be actually faster things comparing to that. I think that would be actually a good exercise to try to implement both of them and compare, say, if you want to use it in Python, if you do it like this versus the way that it is doing through the dictionary and list, which one is doing that. You need to give a large, and so if you want to test the Python, for example, that which one is faster comparing to the other one, you can always test it via, you may run one algorithm, I don't know, maybe with the 1 million items, you may want to run it, I don't know, 1,000 times and see what is the running time of this versus the one running time of that. And you can compare that. What would be this versus that? But anyhow, these are interesting things that this concept of pointers here, for example, we don't have this concept of pointers in Python. Of course, we have them you can have exactly the pointers in C++ if you want to implement this. So this array actually can be an array to pointers. But in some sense, a pointer always is some index of an array. And that's the way that you can do it with this kind of from original to other. And that's a very nice way of implementing this. So is it clear? Any questions? So do you have a question? Yeah. Yeah.
When you use the original array, how is it making sure like when accessing the elements from the original array, how are you ensuring that it's not different? It's not just scattered from the lost elements. Because like when you increment pointers or zeros,
yeah.
Then it's just going in the same order as it was before.
Here, but here when we are doing one time essentially this. So the question is that when you are doing this change between temporary and original, how you make sure that everything goes well. So in some sense, in that case, then the original would be, I mean, this array. So you need to update all of these temporary things, these things. So all of them will be resetted for the next round of digits. And you can actually, you will just.
Sorry to interrupt. Yeah. Sorry, since we've had an unruly student, we have to be telling everybody now, please use the both exits on either side. The front right now is completely closed off.
Okay.
That's it. Thank you very much.
Thanks. Good. Okay. So in that case, I think we can just use the original array and just update it, and everything would be in this new array that you are doing that. So there is no difference essentially between this and the original. You can. Good. So that's the things for this things. And I think it would be great if you just go and implement them, because then when you implement it, you will see exactly all the details there. And it is a very good implementation things. You can do it with C++ or Python. Each of them would be fine, essentially. Great. So let's go on to the next one. Clear all drawing. So this is another, so this one we went from the least significant one. This is the other one that actually you can go from the most significant one. It is called lexicographic. So this is the other one. It is called lexicographic sort, or the most significant digits. That was the least significant radix sort. This one is the most significant. This one especially is useful for when you are doing the strings. So that one is especially good. The other one, the radix sort, was when you are doing these numbers. This one is especially useful when you are doing with the strings. Of course, you can adopt both of them to work for the other case as well, but that was more natural for numbers. This is more natural for strings. So what is the algorithm here? So the algorithm is very similar to the previous one. Just you are starting from most significant digit essentially. So this is good. Okay, so here you are starting from the most significant digit. Take the most significant digit of each key. Sort the list of elements based on that digit, grouping those guys with the same digit into one bucket. And then you will recursively sort each bucket starting with the next digit to the right. So you are doing exactly the same thing that we were doing from the least significant. You are doing from the most significant. And then, so in that case, essentially you are, it's a little bit different essentially here, is that you are taking the most significant digit. Then you will list the elements that they have that digit, you will put them in the same bucket. Then each of them, you will recursively just sort this particular, not the whole array. Good. So actually the implementation would be very similar to that. Let's see an example, and then we can, see what is the algorithm. By the way, one interesting thing about the radix sort was that it was stable. It is called a stable sort. So it wasn't a stable sort. What's the meaning of a stable sort here? So a stable sort means a sort that if two keys were, one was before that and they had the same key, after sorts, still you will keep the order. So the original order will be kept if the keys are equal. That is called a stable sort. Good. And in some sense, we have used this property when we have done it for radix sort. I mean that when you go to the next digit, the order of this guy will be preserved essentially. So let's go and see this other sort things. Okay, so let's do an example. Say these are the strings that you want to sort. Good. So first we are going with the, so here is the most significant. Most significant means the last character. So here, what is the last character? Here, C, A, B, C, A, C, C. So all of them have the, I mean, just consider the last. Good. Now, what do we do? All of these A guys, so when we are sorting them, so all of the A guys, they are coming first. A. Then the B guys are coming, B, B. Then the C guys are coming, and then all of them are C guys essentially. Then what do we do? Then we go to the next digit. So then what is the next digit here? So the next digit would be, so here for this guy would be empty essentially. For A, there is nothing. For B is here. Okay. Now, this was the part that we were talking about. So you are just sorting the A part recursive. Good. So then you will do the same things for the B guys, which is one element, and then the C guys. So each of them you recursively sort. How do you do it recursively? So here, for example, let me just use a different things here. So you will go to A guys. So the A doesn't have anything, B is here. So in this case, you will just go and sort them according to this. So it is empty here, it is B. So naturally, when you insert it, it would be first, I mean, the A guy, you will put it, and then you will put the B guys. Here. Then here, the B guys would be just the B guys here. And the C guys, you will do, what do you do for the C guys? You will just see the second letter. So it is A here, D here, D here. So you will do again this recursively only for C part. So what do we do? So then you will first you will put the C guys. Then who is the first things? The one that has like A. Yeah. So actually, yeah, that was important. So when you are doing for the C guys, so C, A, D, and D. So in that case, actually, the order does not change. So you will keep the same order because they had the same order correctly. Then you will go to the next digit. The next digit is the one that we are doing it here. So the next digit would be, again, empty here. It would be B here. It would be empty here. And then it would be A here. So in this case, you will put it the first empty, then you will put the A guys here, and then you will put, yeah, you have, but again, so it is important that each of them you are doing it recursively. So in a sense, so here, this CA guys, I mean, both of them was, itself was here. This one CAB guys, they didn't have anything. The only guys that they actually had the same things, CD and CDA. So that part you need to solve recursive. And then you are going according to the last character here. So this was the last character here. That was empty versus is, and then you will sort this. Good. So if you want to do, I mean, recursively, you can just, I mean, do this recursion. How do you do recursion? I mean, you want to, this is the thing that you will get it. So this recursive algorithm that you are doing it, you will have essentially say, we'll call it L sort. So this is the original array that is given to you. You are giving essentially the beginning, the end, and the digit. So def this guy, for example, Python version. Now, in this case, what do you do? So you will just see the essentially the digit, and then for each of them, you will put in a new list. Good. So you will, what do you do? Say this one actually returns a sorted list to you. You can say this is a list, you will put it. So the thing that it returns a list. So what do? You will go there. So then you will consider these digits. For each of these digits, you will insert it into a new list. So, so this is a digit that you want to consider, correct? So then you will go to that digit. Then according to that digit, you will insert them in the different. So you have again a set of lists here. Yeah, actually, it would be better instead of just B and L. That would be easiest thing to just actually give a list here. So L is the whole list that you are giving. So you are giving the whole list. Then according to this digit D, you will create this new lists. So according to this list L, you are creating this different list that you have. And then each of them recursively, you will call with the D +1. When you get the result, then you will concatenate them. So this list that you have, so recursively you will do that. You will get the sorted things, then you will put them together as a one list, and then you will return this concatenated list. Good. That's one way of implementation of it. The issue is that, I mean, this is you may need to create some. So the implementations are a bit, I will say, harder than radixsort that we have done it. But still, there are some implementation that you can do it in place, even like with one or two arrays, the same way that I have mentioned, you can do that. You can think about it. That's actually a good exercise, and you can also check it on the web for the, if you want to do it, not in the recursive way, just like the similar thing that we have mentioned with two arrays for radixsort. That would be good things to do it for this lexicographic sort, and see how you can do it with one array, or like with just the same set of pointers that I have mentioned. That in some sense you need to do the counting, you can insert them, and then yeah. So if you want to do that, actually, yeah. So here I have mentioned just a list for you. So I gave the whole list. That's the easiest way. But actually, the original way that I have mentioned, instead of L, you can just give B and beginning and the end. So you don't need to give the whole list, actually. You can just give beginning and the end. Why? Because what do you do? So you will consider this guy. You will insert it in the corresponding bucket. How do you do it in the corresponding bucket? Using that pointer ideas that I have mentioned for the Radix source. So you will go there according to which place that you need to do it. So when I give the B and L, so it means that, what is the meaning of that? It means that good. So you see, this is the thing that I'm doing. So I have this big array, and then I will give it B and E. This is the beginning and end. And then I will say which digit. I mean, the D is the digit that I have. Then I will go there. Actually, I can just. So in this case, you have B and D. Then you will go there, and now these guys, First, you need to reorder these guys. How do you reorder these guys? Exactly using this idea of pointer that I have mentioned. You will see how many in digit D, how many you have from each characters. You will create that pointer list. Then you will go one more time, and then you will do it. You will do it in a correct grouping. Then when you have, so in some sense you are doing this one, reorder them. So this part that you have reordered them, you have the same thing again. You didn't change any other part of the array. Like in some sense, when you have these recursions only change the part of the array which is related to them. Then when you reorder them, then you have several groups here. So you have some smaller groups here. These are exactly the ones that you have. These are the same group that you have done it using the pointer ideas in the previous case. Then what do you do? That would be essentially B1, E1, B1, E1. This one would be B2, D2. Sorry, B2, E2. E means the end here. And then the other one would be B3, E3. And then the D here would be D plus 1. So you are going to say that, okay, next digit. So these groups that you have created using that pointer ideas, you will give that one to recursive things. And then each recursion, it just goes and works on the part that is somehow designated to that part. Until the size of these arrays becomes 1 or 0, in that case, they don't do anything. So you can actually do this one with recursions, but not giving the list. You can give the list and then concatenate the, but that's not the most efficient way. You can just work on one array. This is the in-place order in some sense. You just change the order of these guys. And then when you have the change the order of this guy, then you will recursively and go on. Still, you need to do recursion. Recursion would be a good thing that you will go on for different digits. In general, recursive, you can make them non-recursive, but sometimes it would be a bit harder to think about it. In this case, you can just use the recursion to go there. And does it make sense, the whole idea? Yeah.
So the number of groups would be the number of keys for the.
What was that?
The number of groups would be the number of keys.
The number of lists, yeah. Yeah, the number of groups would be exactly the number of like different, the number of groups that you will make it for each one is that how many, like these digits, what are the values that you can get it? Or like it can be A to Z, it would be 26. It would be 0 to 9 would be 10. That would be the number of groups that you need to do the recursion. So for anything which has more than one element, you will do the recursion. If it is 0 or 1, you don't do any recursion because that's useless. Good. So that would be actually a nice way to implement this. That would be, these are some sort of thing that is a good example if you want to do for interview or something like this, because that exactly tells you how you should be prepared for this one. You may not know exactly the question that they ask, but generally these are the type of question that they are working. Anything with an array, with a list, that's a typical thing that you will get it in the interviews. More complicated thing, generally you don't get it. So they want that to make sure that you array things, you have the ideas and you can implement them well actually. Good. So that's this is the lexicographic sort. And one other thing. So this is a few comments about it. See. Good. So this one that we had it, we have mentioned this one for strings. However, if you want to do it for numbers, you can do it for numbers. But before doing that, because this is, as I mentioned, this is designed essentially for strings. If you want to do it for numbers, first you need to pad them with zeros. Good. So you need to put, to make sure that all of them have the same length. Then you can actually do it this one, and then you will do this one essentially with the same running time. The running time of this algorithm also would be NK. So this would be, again, so the idea is that you need to, this one, if to prove that, you need to prove it using induction. That, like, if you say that each of these algorithm, if the running time of each of these algorithm is order NK, because this is a recursion. Now, for example, you are breaking this guy. So you have this particular, this is the one that I mentioned. This is the beginning, this is the end. And then you try to recursively sort this one. So in that case, you need to first do one linear scan, which would be E minus B. And then this is like some of this that you need to do it, this one. And then you need to do recursively for each of them. For each part that you are getting smaller things. So what would be the type of recursion that you want to say? So if you want to say that, if you have a D prime digits remaining, so if you have D prime digits remaining, then the running time of that recursion would be D prime times E minus B. That's the type of, this is the induction hypothesis that you need to have. So if you have D digits remaining, then, and you want to sort it in E, like beginning B and end E, the running time of that would be E minus B times D prime. If you have this induction hypothesis, then you can say that then you can apply this one for each of these red guys, and then you will say prove the whole things for the blue guy, which is one digit. It has the, so here, when we are doing for these guys, this is essentially D prime would be, this one for these guys would be D prime plus 1. Because this one has one more digit to solve. So you have one more digit to solve here. And then you want to say that if you have this one, then it would be D prime plus 1 times E minus B of this. But here I should say that is actually, this is EI BI. So this you will apply it for these red guys, then you will get the whole things for the blue guy, induction hypothesis. That's again a good exercise to do that. So this is sometimes it's like a graphical one is like a more advanced things that you need to think about it, how you can get it. I mentioned the ideas here and also the ideas of implementation, but it would be great if you go and actually implement it. It's a good exercise. I mean, these are like, if you want to do for interviews, it's like, let me just do that one, because if you do it right way, then actually the question that you will see at the interview probably would be much easier than this. Good. So I think, yeah, so that's it. So we have talked about this. As we mentioned, how you can apply it for the sorts. If you want to do the digits, you can actually do it like this, and then you will sort it. And yeah, I think that's about this one. This is also a good exercise. You can think about, can you adopt? So I mentioned how you can change this one, such that you can use this lexicographic sort to do the sorting integers. You can think about how you can change radix sort, such that it can sort strings. Good. We want to use radix sort to sort strings. Think about it. That would be good. Yeah, so that's it essentially. So we have this type of sort. We will talk next time. We want to talk about a quick sort, but before that, we need to talk about probabilities, because quick sort is some algorithm that use probabilities. So this is a crash course that you will have it in probability theory, and that we will use it for the I mean, you will use that for the all future classes. I am teaching next year. I'm teaching a course on introduction to computational game theory for undergrads. For example, that's the one that you can also do some of these things. Yeah, I mean, yeah, if nothing happens, that would be the current plan. But that would be like in game theory, we are using lots of probabilities. If you want to do machine learning, you need to do lots of probabilities. So we will talk about them, and you will see some essentially examples in the class for quicksort and more things in the future for future. Good. If there's a question, can answer. Good. So if there is no further question, we will continue in the next session. Thanks and bye.